In this video, we are going to factor a type of polynomial which is a little bit different from what we have seen before. What I'm going to do is that I'm going to introduce a new variable call it, let's say, z equal to x squared. So let's say z is equal to x squared. Then this polynomial becomes z squared minus 7zy plus 12y squared. Now this is quadratic in terms of variable z. The leading coefficient a is equal to 1, b is negative 7y, and c is 12y squared. Since the leading coefficient is 1, we know that it's possible, not necessarily factorable, but it's possible to use the sum product method. So if we can find two numbers that the product is 12y squared and the sum is negative 7y, we can factor this one. So hopefully we can find those two numbers. Now, since this is quadratic in terms of z, I'm going to have two variables z inside the bracket. Now, the product is 12y squared. So those two numbers can be either 1, 12, 2, 6, or 3, 4. But since the sum is negative 7, this means that the two numbers I can pick to be of the same sign and both to be negative. So let's try negative 3y and negative 4y. Negative 3y times negative 4y gives us 12y squared, and negative 3y plus negative 4y gives us negative 7y. Now I'm going to replace z with x squared, so I'm going to get x squared minus 3y times x squared minus 4y. To test again, I'm going to use the arrow method. X squared times x squared gives me x exponent 4. X squared times negative 4y gives me negative 4x squared y. Negative 3y times x squared gives me negative 3x squared y. So the sum is negative 7x squared y, which is this one. And negative 3y times negative 4y gives me 12y squared. So I was able to factor this polynomial. The next example is the following. We have to find the factors of x exponent 6 minus 3x cubed minus 54. Again, I'm going to use a different variable to get rid of x exponent 6. So I'm going to introduce z equal x exponent cubed. So above becomes x exponent 6 is really z squared. X exponent 3 is z, so this is negative 3z, negative 54. Again, a is 1, b is negative 3, and c is negative 54. Now, we have to find two numbers that the product is negative 54 and the sum is negative 3. Hopefully we can find those two numbers. First, we know that we're going to get two brackets. The variable is z. Now, we know that a pair that gives you 54 is 9 and 6. Since it's negative 54, so one of them has to be negative. But the sum is negative 3. So this means 9 has to be negative. So I'm going to get x minus 9 and x plus 6. Again, to test, I'm going to use the product of the two brackets, arrow method. Z times z is z squared. Oh, before I do that one, I'm going to replace z with our x cubed. So this becomes x cubed minus 9 times x cubed plus 6. Now I'm going to find the product of these two binomials. X cubed times x cubed gives me x exponent 6, which is the first term. X cubed times 6 is 6x cubed minus 9 times x cubed. 9 minus 9x cubed gives me minus 3x cubed, which is this one. And minus 6 times 9 gives me negative 54, which is the last term. The last example is a little bit tougher. We have to factor x cubed plus 9x squared plus 27x plus 27. Again, there is no single process that we can follow to factor this one. We just have to try different methods. Hopefully we can find a way to factor this polynomial. What I'm going to do, I'm going to add 3x squared and then subtract 3x squared, which I can do it because I haven't changed anything. Adding and subtracting is the same term. But now I'm going to take the first term, the second term, and 3x squared together plus, so first term, second term, and 3x squared together, and then 27x and 27 together. So I'm going to get x cubed plus 9x squared plus 3x squared plus 27x minus 3x squared plus 27. So this is exactly like the expression we had before. Now x squared, 3x squared plus 9x squared is going to give me 12x squared. So I'm going to have x cubed plus 12x squared plus 27x minus 3x squared plus 27. Now take these three terms together and these two terms together. The common factor between these three terms is x, so I'm going to get x times x squared plus 12x plus 27. And between the last two terms, I'm going to common factor negative 3. So I'm going to have negative 3 x squared minus 9. Now, this bracket, as you can see, the leading coefficient is 1, so hopefully I can use the sum product method. And here, again the leading coefficient is 1, so I can use the sum product method. First bracket, I have to find the two numbers that they multiply to 27, they add up to 12. Those two are 3 and 9. So I'm going to get x times x plus 3, close bracket, x plus 9. minus 3. Now, the second bracket is very interesting because there is no middle term. This means b is 0. So this means that I have to find two numbers that they multiply to -9, then they add up to 0. Those two numbers are 3 and -3. So I can write this guy as x minus 3, x plus 3. Now, if you look at these two, this term and this one, x plus 3 is common. So I'm going to take x plus 3 out. From this, if I take x plus 3 out, I'm going to get x times x plus 9, which I can write as x squared plus 9x. And from this, if I take x plus 3 out, I'm going to get -3 times x minus 3. So if I distribute -3 inside, I get -3x plus 9. Now I'm going to end up with x plus 3 times x squared. 9x minus 3x gives me plus 6x plus 9. Now this is x plus 3. Now the leading coefficient of the second term is 1. It's a quadratic, so finding two numbers that the product is 9 and they add up to 6. Those are 3 and 3. So I'm going to get x plus 3 times x plus 3. Now you have three terms which are the same multiplied together, so I'm going to get x plus 3 exponent 3.